Thank you for tuning in to the Zealous Podcast. I'm your host, Rocky Snyder, and hopefully you're subscribing by now. But if not, if you're new to the podcast, do hit the subscribe button, please. Follow us on Instagram at Rocky_Snyder. And this week, we've got Professor Paul Comfort, Professor of Exercise Science from the University of Salford. He's going to be talking a little bit about what he's going to be presenting at this year's national conference for the NSCA. That's going to be in July on the 12th to the 15th at Caesars Palace. We're going to dive in a little bit about what his research entails, what he's been teaching, and a little bit about what it's like for strength conditioning in the UK. I hope you enjoy our conversation, and here we go. I guess it's not off topic, it's actually on topic. You're going to be presenting at the national conference, and you're over in the UK?
Yep, that's correct.
How is the NSCA community in the UK? Is it flourishing? Is it small? What?
It's relatively small. It used to be bigger, but it's relatively small just because we've what would it be? Probably about 18, maybe 20 years ago, the UK established its own strength and conditioning organisation, the UK Strength and Conditioning Association, which to me really has the gold standard in terms of the accreditation process, because you have to go through a multiple choice exam similar to CSCS, but then you have to actually coach an individual, go through how you coach weightlifting exercises, back squat, deadlift, etc., how you would run a warm-up, how you would coach plyometrics, change of direction, and present a minimum of a 12-week case study of an athlete you've worked with the evaluation at the beginning, needs analysis right the way through, evaluation at different points throughout that 12 weeks or possibly longer, and re-evaluation at the end with a reflection on what went well, what could go better, were you too conservative on anything, etc. So most of the time in the UK, it has the UK SCA accreditation as essential when you're looking at the different job adverts, and CSCS is a desirable. So I think that's part of the reason. I do think it will change slightly now that the NSCA is going for accreditation of degree programs. And with that accreditation, I think that will help, as long as they launch it internationally outside of the US relatively soon, before anyone else then monopolizes the market in other countries, because I don't think any institution anywhere in the world will pay for multiple accreditations. They won't want to be accredited with, the UK SCA, the Australian Strength and Conditioning Association, the National Strength and Conditioning Association, because, they're thousands of pounds each, and no one's going to want to pay for everyone. So I think, that needs to happen soon. But it's good. There's quite a few people from the UK that attend the NSCA conferences regularly, but it could definitely be better.
Yes, no, I agree. I've often wondered why we don't have practical application as part of the examination process. And in the early years, I understood the reasoning is the subjectivity of the examiners, but there must be certain kind of objective measurements that could be used in regards to watching somebody coach.
Yeah, and I know that there's still some dispute sometimes about the equivalent sort of processes with the UK Strength and Conditioning Association, and some people feel very hard done by if they fail a component of assessment, and maybe it's just a difference of opinion, or you've got a tick sheet and you didn't say a specific word, so they didn't tick that box, but you might have said an alternative word which means the same thing. So there is a subjective aspect to it, but I think it can be achieved. And I actually think it's really important that it is achieved. How that's going to be achieved will be difficult. The accreditation of programs will help, because they're expecting, throughout your bachelor's degree, for you to have been assessed on all of those different competencies. The main thing you need then, though, is the instructors have to also be competent at all of those themselves, which is not always the case. And I've seen that in the UK. So in the UK, with universities, you have to have an external examiner, so somebody else that comes in from another university and just evaluates your processes and your procedures and how you examine the students, the teaching practices. And I've seen some fantastic examples where I've gone, right, we're going to adopt that at my institution. That works really well. That's a really good way of doing it. It engages the students while we'll do that. I've also seen at some institutions where I wouldn't recommend anybody attends. because the theoretical aspect may be fantastic, but if you've got somebody that's never coached, teaching practical side of things, so they're trying to teach weightlifting, your standard gym exercises, plyometrics, change of direction, but they've never coached that. You can tell they've never coached that.
Mm-hmm. Quite readily, I'm sure. What's your talk for the listening audience now? What talk or topic are you going to be presenting at the NSCA conference in July?
I've got the honour of delivering the Michael H. Stone Sports Science Lecture, so there's no pressure there. And the topic is going to be strength, the foundation of performance. So I better do it justice.
How did you get stuck? I mean, how did you get selected for something like that?
It goes through the conference committee. I think it's also the research committee and Professor Stone himself, which is the bit that then puts you under a lot of pressure, because I know he'll be sat in the audience. But I'm also lucky that I'm helping one of my colleagues do a sort of practical. Well, there'll be a combination of theory and practical on the Wednesday morning as well. Dr. John McMahon's delivering a session on the use of force plates to evaluate neuromuscular function in design training programs based on those evaluations. So that one's going to be far more interesting and enjoyable for me, because I think I'll be a little bit nervous with the big presentation.
Now, how much experience do you have with force plate technology?
Quite a lot. We've used them very extensively at the University of Salford, where I'm based now, for the last 15 years. So yeah, we've been using it a lot, starting off with a very much the laboratory-based side of things. The in-ground force plates. We had some Kistler force plates, which are considered portable, but they're very heavy. They're probably about 20 kilos each. Then you have to plug everything in, cables running everywhere, which in an applied environment, if you go out to a sports team, is difficult. And then it takes you, a full day of copying and pasting force time data into an Excel spreadsheet to analyze it and then be able to generate reports for them. Now things are much better. Now there's multiple systems on the market where you collect the data, and under a second it's analyzed and it's on the screen in front of you. So yeah, quite a bit of experience, and it's been nice to see the evolution of force plates and how they're used over the last 15 years.
Yeah, I think you're part psychic here, because that was going to be my next question, is because of your longevity with force plate technology, what has the evolution of this device or technology been like? Where from where it was to where it is now, what are the major stepping points or landmarks that, in your opinion, have progressed to where we are now?
I think it's really that advent of having it fully automated, so that you can collect the data, and like I said, within under a second, you've got that information there on the screen in front of you, all analysed, so you can give feedback to the athlete, which helps get buy-in from the athletes, from the coaches, etc. And it was actually, I think, the first system, I may be wrong, the first system on the market, I think, was set up by Dr. Phil Graham-Smith, who actually employed me at the University of Salford just over 15 years ago. So he set up Force Decks, which are now part of the Valve suite of products. So he set that up partly because we were going out testing at a range of different clubs, and it was taking days to analyze all of the data. If you analyze 50 or collect 50 or 60 athletes worth of data, multiple jump trials, so it could be a counter movement jump, a drop jump, an isometric test, it takes you days to get that information back. So he wanted to automate it, and partly to save us time, but because it's the way, it was always the way ahead. So he set that up. Since then, there's been other force plate manufacturers. So Kistler now have a Mars system, which automates the process. Hawkin Dynamics have got, they brought up what was the first wireless system. So you didn't have to be connected to a laptop, which makes it even better. It's just on a tablet. And again, other companies now have gone and done the same thing. And that makes it much more user-friendly, much more portable. You can use it pitch side, you can use it in the training venue, you can move it about, which is great. The biggest problem is, though, because it's sort of plug and play, you can buy it, you can watch some YouTube videos of how to use the equipment. There's a lot of practitioners that don't really know how to do things properly. And most of those companies will give you 100 variables or more for a counter movement jump. Most of them you don't need to know. Some of them are nonsense. So you need to understand which of those variables you do then select. And the standardization of testing procedures, something as simple as if you cue a person to jump as high as possible, or you tell them to jump as fast as possible, you'll get two completely different jump strategies. So it's essential that all of those things, not just how you set it up, but actually how you get the athlete to perform the test, the cue for them, all of those have to be standardized. Otherwise, across testing points, or if I test somebody today and you test them tomorrow and you cue them differently, it's not that you're doing it wrong, it's just different. So all of that has to be standardized, or we'll look at the variables afterwards and think, what the hell does this mean? It's changed far too much. Surely that doesn't make sense. But yeah, there's a lot more education in this area that I think we need to do.
Well, it sounds like you have a standardized approach within your own university. Is that true?
Yeah, that's correct. So, and if we take multiple members of staff or doctoral students, or even sometimes undergraduate and master's students out to collect data at different, primarily soccer teams, but also some rugby league and rugby union teams, we bring them in beforehand and we'll make them do at least two sessions of going through data collection and make sure it's standardized. And the final one of those before we go out and test will be getting everyone else to run all the tests, analyze the data, interpret it, and just a couple of us will stand back and just watch and see, are they standardizing it? Is it done exactly how it should be? Or have they done something slightly different? To make sure that on the day, it runs as smoothly as possible. Because you don't want to be having to turn around and say to athletes, sorry, I got that wrong. Can you come back and do it again? If the athlete performs it wrong, fine. But you don't want to do something wrong and then have to, eat into the athlete's time to do some additional testing.
Certainly.
But yeah, very, very standardized.
When it comes to the coaching cues, of course, words are very important. Yet I'm wondering, when you take force plate technology into the weight room, do you have specific lifts or movements that cover all the athletes, or are you more sport specific in some regards? How does it work in the weight room?
Yeah, I wouldn't say it's sport specific as such, because what we're trying to do is assess certain physical characteristics. So we're trying to look at maximum force production with a maximum multi-joint isometric test. Normally the isometric mid-thigh pull, you can do an isometric squat. Some people are playing with an isometric belt squat, but there's no standardized protocol for that yet. But hopefully we'll get that sorted soon. We do a counter movement jump with hands on hips. And it's hands on hips because we want to make sure that we are assessing lower body neuromuscular function for a ballistic and sort of slow stretch shortening cycle task. If you add in arm swing, you can just train somebody to synchronize the movement of their arms more efficiently and they'll jump higher. That doesn't mean they're doing anything more efficiently with their legs. It's just a better arm swing. And then we normally do a counter movement rebound jump. So a counter movement jump immediately followed by a rebound. For rapid stretch shortening or fast stretch shortening cycle capability, so a more plyometric type task. And there are other options with that. You could do the 10-5 test, which is a counter movement jump followed by 10 rebounds with a really short contact. No force plate systems analyze that data any better than using a jump mat though. It goes off contact time and flight time, and athletes generally perform the best on rep 5, 6, 7, 8, and 9. So what's the point in doing all those jumps before? They use a pacing strategy. Most athletes are quite clever when it comes to athletic tasks. So, there are other protocols you can use. You can do 5 jumps or 3 jumps. We go with a counter movement and 1 rebound. And we do that instead of a drop jump because nobody drops from the height of the box during a drop jump. There's a series of studies going back to the 80s and some more recently where on the box, they'll either plantar flex and, almost jump off. Most will step down, and the height of the fall height can vary by as much as 20% of the box height. So if you've got a 40 centimeter box, you could be dropping from 32 centimeters or 48. Well, if we're looking at that longitudinally, how can we really compare? Because I might get a much better reactive strength index later on because I've cheated and stepped down, whereas the first one, I thought I was going to be great, and I've jumped off the box, hit the ground harder than expected, and my reactive strength capability didn't look as good. There is still, to some extent, a bit of an issue with that with a counter movement rebound jump, because what if somebody's jump height improves massively? What if my counter movement jump height goes from 40 centimeters to 50? When I then do a counter movement rebound, I've got a more demanding task. But people don't tend to improve that rapidly, unfortunately. Counter movement jump height tends to be relatively stable. So they're the sort of three tests: an isometric mid-thigh pull, a counter movement jump, and a rebound jump. We do sometimes do some of those alternative variations if that's what the sports team prefer, but we make them very much aware of the limitations of those different tests.
And then how do you establish upper body power with force plate? Do you do that at all?
No. And the reason being, you can't use the same calculations as you can if you're looking at, let's say, a press up. If you're trying to do a more ballistic press up type movement, because your feet are on the ground, you don't have your full system weight or system mass applied to the force plate. And then as you leave the ground, or as you go from sort of being in a full press up position to fully extended, that mass changes. So it doesn't allow you to calculate things properly, which is limiting. In fact, most upper body tests of power are limited, unfortunately. Even if you do something like a bench press throw, we've got a device at our university where you can do that, and you can attach the bar to a cable with a braking device, and it will hold it there. But I'm pretty certain no one puts in a maximal effort, because you end up with a bar of whatever load suspended above you on a single cable, and you're still a little bit nervous that thing might come crashing back down. And actually, in the majority of sports, lower body power is far more important than upper body, because we're looking at propelling ourselves around a pitch, court, etc.
Yeah, so when it does come to taking the force plate out to the pitch, what does that look like? What are you using the force plate for with your football players?
Again, if we're doing that, it's really to try and assess fatigue, either during training or pre-post match. So you'd normally put it, force plates have got to be not on the pitch as such. I've seen people doing that, but it needs a solid surface. You need a bit of concrete that's flat. But that can be, right by the side of the pitch, or it can be just in the sort of dugout area, or as they walk out to go onto the pitch. And that's really then just to assess how fatiguing some of those tasks are, and if it's actually negatively impacting neuromuscular function. What sometimes happens though, and we haven't published anything on this, but we've got some pilot data. So again, one of my colleagues, John McMahon, and one of our current master's students, Ryan Spencer, collected some data post-match and found that actually jump height in some cases improved after a 90-minute soccer game.
What do you account for that?
Oh, it was quite easy. At first we were scratching our heads, and then we looked. Yeah. Body mass had decreased by around about 3 kilograms.
They had sweat off so much; they were lighter.
So they've lost a lot of sweat. They weigh less, and we looked and said, "Well, hang on a moment. Their impulse is lower. So if their impulse is lower, they shouldn't be jumping as high. So how are they managing to do that? But their impulse was only slightly lower, and the decrease in body mass was greater than the decrease in impulse. So you still ended up with a similar or higher jump height." And I don't think anyone's taken that into account in any of the research I've seen published where people have looked at, fatiguing protocols when it's simulated match or competition. I don't think anyone's ever reported changes in body mass post fatiguing activity. So it's really important to take that into account. Mm-hmm. Because if they're jumping the same height but they're 3 kilos lighter, to me that's telling me they are fatigued. They're only jumping higher because they're 3 kilos lighter, or however much mass they've lost.
Interesting. Now, I love geeking out on this stuff, so bear with me now. Do you do assessments at the half, at the end of regulation, and then also potentially after stoppage time? Like, of course, it's going to vary from 2 minutes to 9 minutes in essence, but or is it only after regulation time, only after a match, no matter how much time has transpired?
Yeah, so far it's just been sort of pre and post match, because at half time it's very difficult to get all athletes through testing. We're really lucky at the moment. We've got, they're stopped in customs at the moment. We should be receiving another 3 sets, I think, of force plates. So we'll end up with 7 sets of the Hawkin Dynamics portable force plates that we can take off site. So then we could test the whole squad in no time at all. Normally we take 3 or 4 sets with us. So it will improve our capability of doing some of these things in the future. We've been lucky to secure little pots of funding, some internal, some external, and slowly build up the amount of force plates we've got. So we're very lucky. And
Yes,
we've
you
also got
are.
a PhD. Yeah, and we've also got a PhD funded by Hawking Dynamics as well. So the PhD student, Andy Babby, is really digging into some of these areas. And one of the things he's going to look at is what happens, post-match in more detail across multiple games, and then also look at, is there an effect of playing time? Because if you go on at halftime and you've only got 45 minutes, work rate tends to go up. Whereas if you're playing for the full match, there is a bit of a pacing strategy. So we also need to factor in all of the information from GPS. So how far are they running? Is it much greater than normal? And you need to know what's normal for them. Because if it's exactly the same as they normally do, it shouldn't be particularly fatiguing. Whereas if on one day they're playing a match and it's much more intense, they're having to defend and attack a lot more than normal, that's likely to be far more fatiguing. And then we've also got to identify, well, is it the number of accelerations, decelerations, which is inducing fatigue? Is it the total distance covered? Well, to be honest, if you look at a soccer match, even at the sort of Premier League level, if you're looking at 12 or 13 kilometers in 90 minutes, that's not a fast pace. The average pace is really low. In fact, I think most people who are physically active could cover 13 kilometers in 90 minutes. But what we're not doing is all those rapid accelerations, decelerations, change of direction, jumping to head a ball, etc. And then it becomes a whole different ball game altogether if you're looking at rugby league or rugby union with the collisions, because then you might have a decrease in function just because you've taken a huge impact to your thigh.
Yeah. So that actually leads into my next question. You bring up the Premier League. You're in a university setting, so primarily you're looking at your university level players. But are you also venturing forth and reaching out to Man City, Man U, or any of the lower level clubs in terms of Premier League or otherwise?
Yep, to be honest with you, we don't do much with the university sports teams because unfortunately, sport in the UK and UK universities is nothing like it is in the US. It's very much amateur. It's just very, very amateur. There's very few universities that offer sports scholarships. And that's partly because of the setup of sport in the UK. If you want to become a really good football player or soccer player, you'll be in an academy setup with Manchester City, Manchester United, Liverpool, Everton, whoever, from the age of about 9 years of age. So they don't have to go through the system in the same way that you do in the States. So it does mean that most university athletes aren't anywhere near as good as they would be in the US. So we can use them for some studies, but almost to profile and say what's the physical characteristics of people at university level in the UK. There's not really much point.
So you directly go to the academies then?
Yeah, so most of our work is done with the different sports teams, the professional sports teams, and we've been really lucky. We've got a lot of master's students that have or are based at places like Manchester City Football Club. We've got a PhD student who's the head of fitness or physical performance or whatever his title is at Manchester United Football Club. So we're really lucky in that respect. And a lot of our students that have graduated from our master's program now work in sport, not always at the Premiership level, but at the lower levels below that. So we're looking at a lot of that data, collecting a huge amount of data with them pre-season and sometimes throughout the season, and doing the same, as I said, with rugby league and rugby union where possible. Although the density of soccer teams around where we're based in the Greater Manchester area is huge. It's definitely the primary sport that everyone watches and plays, so it's much easier to collect data in that sport. And we're lucky because at the Premiership level, they've got really good facilities, they've got a huge amount of staff. But below that, you drop down one tier and they don't have the facilities and the resources, or again, they might have one set of force plates, but they want to test an entire squad. And the coach or manager gives them an hour. Well, if you're only doing a counter movement jump, you're okay. If you're doing more than that, you're struggling. So we're lucky that we get invited to go to a lot of the teams. I think we've got 7 or 8 signed up already for the last week of June and the first week of July for pre-season training. Some with the first team, some from the academy age groups, right the way up to the first team, where we'll go in and basically do all their pre-season testing for them. As I said, take 4 force plates with us, normally set up 2 isometric testing stations, set up 2 jump testing stations, and we'll get through a squad of about 30 athletes within 45 minutes to an hour. And then we can automate the reports and get that data back to them again in under an hour after we finish testing.
But that's remarkable. That's just,
and I think that's why we keep getting invited back, because it's a pretty slick setup now, and partly because we've been doing it for so long, and partly because we've got that consistency of people that are doing the testing, and we've even got one of our previous PhD students. Well, he actually did his PhD at the University of Murcia in Spain, but spent a year with us. Not at all looking at football. He was looking at different weightlifting exercises. But now he's out working at a university in Madrid, so he's been going around some of the La Liga clubs, Real Madrid, etc., and testing them and taking his team out. So we trained him up. He's now trained them up, and they're replicating some of the stuff out in Spain. So we're developing this huge sort of network of data collection and a huge amount of data, so that we can really benchmark across a whole different levels of competition to find out, what is good, what is bad, what do they need to focus on. And that's in summary, it's easy. It goes back to my presentation at the NSCA. They need to focus on strength. They're generally all really good at jumping, producing force rapidly. They just can't produce much force.
And just because their strength levels are low?
Yeah, they don't do much strength training. There's lots of pitch-based training. Most of it revolves around running about with a football. And the general strength training practices of soccer in Europe are pretty substandard. They do some, but it's nowhere near the level that you would expect. It's done really well at academy levels, because they're trying to condition those athletes and get them strong and robust. They go to a first team setting and they generally decrease the amount of strength training they're doing, and things start to deteriorate.
Is that
but it's a big miss. Yeah, I think so.
Yeah, it's more cultural than anything else, right? Or is there an apprehension, or I won't say fear, but of injuries if they are doing that? Because there is that shadow for many decades now that if we're going to be doing strength training, that could increase the potential for injury. Or what do you attribute it to?
Yeah, I think there's a range of things. I think one is people are scared of injury, so there's a bit of an ignorance in those areas. They also confuse delayed onset muscle soreness with injury. The athletes do, not the staff. But if you think about it, if you have a period of fixture congestion, so you're playing 2 or 3 games in a week for 3 or 4 weeks, so they pretty much stop any strength training. Then you go back to your normal strength training session, but you've not done it for 3 weeks. If you've had a 3-week vacation and then you go back your first training session, you feel fresh, you feel good. The next day, you don't feel good. But that perception is, I've pulled my hamstring, I've pulled my groin. No, you haven't. You've got a bit of muscle soreness. So it's conditioning people to make sure they understand that, and make sure that you might do a suboptimal training program for a few sessions, but it's better than doing nothing, and better than doing something that's so intense that the athlete says, I'm not doing that again. I was sore, or I injured myself, even though they're not really injured. And I think it's that understanding of the underpinning physics and biomechanics and physiology of how do we generate forces. And if we want to be faster, we have to generate a higher impulse. And if you're producing 90% of your force within a really short time frame, so you're efficient and effective at producing force, the only way you're going to generate greater impulse is for you to just get stronger in general. So we've got athletes that are when we're testing them, they might be expressing somewhere in the region of 90% of their maximum isometric force during a ballistic task. So the thing that's limiting them is not how efficiently and effectively they can produce force during that ballistic task. The ceiling's not high enough. They're expressing the force that they can express very, very efficiently. We need to raise the ceiling. And the only way of doing that is a period of focused, higher load strength training. But again, there's that fear then, well, will it fatigue them? Will they get injured? And you still, I don't know what it's like in the States, but we still see it now where people say, we'll do a deload week, we'll back off slightly. So they reduce the load and they do higher reps, similar number of sets. So your volume load actually goes up. That's more fatiguing. And it's that, understanding what causes fatigue. And I think sometimes you just have to take that step back and think, well, actually, if I'm normally doing 5 sets of 5, and then I go into a period of fixture congestion and I drop down to 3 sets of 3, my athlete is not going to be fatigued. I've had a huge reduction in volume from that athlete. I've still used the same load, 3 sets of 3, non-fatiguing, but enough of a neurological stimulus to maintain that force production capability. They won't be fatigued. They definitely won't be sore because you've reduced the volume so much. But it's difficult to get people to understand that.
Yeah, very fascinating. So for me in particular, when we talk about force plates, I have one here in my facility. However, I don't use it in the same regard. My force plate is primarily for understanding where a person's resting posture is as they stand upon it, to understand where three-dimensionality, where their structure is, where the stress points are, what muscles are in a resting position, in a shortened state or lengthened state, and then how do we create a more balanced structure based on those results, and then we use it to reassess and so on. I bring this up because there's many ways in which to use these tools, and in the time that you've been using it, Paul, I'm curious, have you kind of just started kind of playing around with it and discovered, here's something that would be kind of nice to moonlight with, not necessarily take on to the players or even to present to the academics, but just something that is an offshoot, a surprise kind of option that you could use the force plate for?
To be honest, I think it's probably the reverse. We probably started off 15 years ago looking at this huge, broad range of things that we could try and include, and then either find that they're so variable, there's no point doing it, or it doesn't link to performance or injury when you follow it over time. So let's put that to one side. Let's not bother. Even things like asymmetries. So, you've got 2 force plates, make an individual jump. Make them do 10 counter movement jumps. And they will favor one side. But that will change between trials. So you might get somebody that jumps and 6 out of 10 jumps, they favor the right leg. And then 4 out of 10 jumps, they favor the left leg. So that's not an asymmetry. So we need to look at those individual trials. But if you average it out and you only look at the average across those trials, you'll say, yes, they're asymmetrical. But if it varies each time, that's just variability in their movement strategy.
Mm-hmm.
So, and that happens all of the time. So the other thing you could then consider is, well, what about if we do a unilateral jump? Make them stand on one leg and perform it. Well, most people can't stand still when they're on one leg. So then you make the assumption when you're calculating acceleration and velocity with a force plate that mass at the start is constant and velocity is 0. But if you look at the force trace, you'll see it undulating. So trying to get them to stand still so we can calculate accurate variables thereafter is really difficult. Surprisingly, you're just standing on one leg, but it's still difficult. So what they start to do then, if it's a jump test, is they'll stand with a slightly flexed knee and hip. But then when you calculate jump height afterwards, because their center of mass was lower than it is when they take off, that also increases the amount of error in your calculations afterwards. And the level of flexion at knee and hip will change between testing sessions. So basically what we find is when you try and do that testing, and we need to do more of it to figure things out and try and find a better approach. But it's too variable and it's not reliable enough. So your measurement error slowly increases. So you then might go from something like with a jump, looking at measurement error on your key variables of being less than 5% with a bilateral task, to suddenly being up closer to 15%. And you're not going to, regularly see a change greater than 15%. So, as I said, there may be things we can do, and this is something we need to look at in more detail, to be able to standardize the testing procedures of the unilateral task and improve the reliability and reduce the measurement error. And if we can do that, we'd reintroduce those types of tests. But even things like, time to stabilization, if you do some form of hop onto a force plate or jump onto a force plate, see how long it takes for you to stabilize and be completely still. We've got a huge amount of data on it, but it just never links to injury risk, function, strength, or anything else. And if someone's really poor, you can generally tell they're really poor without using a force plate. If you're looking at something like center of pressure and their sway. So yeah, we've tended to have actually reduced down the testing batteries more and more and more. so that it's as time efficient as possible, and we can try and make everything as meaningful as we can. That doesn't mean we won't go back to some of those testing methods in the future and try and refine them and find a much better way of performing the test, cueing the athlete, because that's certainly where some of the limitations are.
Paul, what about other sports aside from football/soccer? Do you have other athletes, whether in or without of the university, that you're working with the force plate? I know we're talking all about force plate just because it's something that I think there's a desire within the listening community to know a little bit more about this emerging kind of technology. But it's not just football players that you're working with, is it?
No, it's rugby union, rugby league, and then we do have a range of other athletes that we test. We've actually got one of our master students has lined up to test American football players. Again, the performance characteristics of those in the UK is not going to be anywhere near what it is for the NFL players, but he's got a large sample of athletes we're going to be evaluating there in probably the next few months. And we've worked with a whole range of other sports: netball, basketball, dancers. So yeah, quite a range of different people. And we use the same sort of tests with them because, as I said earlier, we're looking at, right, what's their maximum force generating capacity? What can they do during a more ballistic task with a slow stretch shortening cycle? And what about with a fast stretch shortening cycle? And you tend to find that those groups of athletes perform in similar ways. So the football or soccer players are generally weak compared to what we would like them to be, but their ballistic and plyometric capability is generally very good. If we look at rugby league and rugby union, the same as you would get with players in the NFL, they are generally really strong, but their ability to apply that force during ballistic or plyometric tasks isn't always as good as we would like it to be. So that tends to be the area they need to focus on more. Not always, there are exceptions to the rule. There are still some athletes in those groups who are physically gifted naturally, and you look with one or two and think, why do we start with this person? They're fantastic. And then there are others where you look and think, this person looks great on the field of play. They look great on the pitch, but how the hell do they look great? Because all of their performance characteristics aren't very good. They're not particularly strong. They're not particularly powerful. Their aerobic fitness isn't as good as it could be. But then when you actually watch them, they're that one anomaly who is very gifted in the sport. They can read the game really well. They're never out of position. They're always where the ball ends up. You'll see them drifting across on the pitch and think, why are they moving over there? And then the ball ends up where they are. So, they can get away with it because their ability to understand and interpret the game is phenomenal. But yeah, it's nice to work across those range of sports because you can look at the training practices and easily see how each of the different sports could learn from each other. Even if you look at dancers, the dancers generally aren't particularly strong, but their vertical jump capability, especially if you look at something where they take a one-step approach and then leap, or a few steps and then jump, they're absolutely phenomenal. They're so efficient at movement, and they look, as you would imagine, they look extremely graceful when they do it. But again, their limitation is most likely the fact that they're producing their force very efficiently. They just need to be able to produce more.
And out of all of these athletes, you mentioned the dancers being surprisingly powerful in regards to a one-step jump and so on. But out of all the sports, is there one that keeps coming back as the most powerful athlete?
Yeah, it's probably some of the rugby league players. So listeners might not know the difference between rugby league and rugby union, but the rugby league players, they do have a scrum, but they don't really push when they go in the scrum. The ball goes in, gets fed straight out the back. They don't perform the line outs where they lift people in the air, and because of that, the forwards are nowhere near as big as you get in rugby union. But you get some of those, and also some of the sort of the fullbacks and the centers who are very big, not by American football standards, but you'll have some of them that may be 100, 110 kilograms, who can run, exceptionally fast sprint times, can jump 55, 60 centimeters, but at 120 kilo body mass is great. I've seen some of the data from the NFL Combine, a few weeks ago, and some of those were performing some fantastic feats. I think the average was about 55 centimeter vertical jump with hands on hips. And this is on a force plate, and the highest was up in the 70s, which again, for an athlete who's 110, 120 kilograms, the momentum that they're achieving and the force they're applying to the ground to achieve that is fantastic. But I think that's because, they're with the rugby league players, they're a little bit more of an all-round athlete. They have to be able to accelerate and decelerate quickly. They go into the collisions in a similar way, but it's a much, much faster pace than you get with rugby union. They're not going to be as strong or as powerful as you get with American football players because of the stop-start nature of the game. Because you don't have to do anywhere near as much aerobic conditioning as you would do for something like rugby league or rugby union. So you can emphasize a lot more development of strength and power and muscle mass. But again, I think that's where it's interesting is you can then look at the training practices and say, well, what is it that they do across these different sports, which gives them that increased physical capability? What can we take away from one sport and use in another? But again, making sure it is context specific, because you still have, if you going back to using soccer or football as an example, they're averaging a heart rate of about 85% of their maximum for 90 minutes. They're working hard. Their VO2 max, their aerobic capacity is phenomenal. And you have to have that, otherwise you'll never make it through the entire game. And then if you go to play at the national level, if you're playing with the England team, that's a step up again. So you've got to have a huge engine. But at the same time, it's no good being able to perform those tasks if every time you come to challenge an individual, they can out-accelerate you, they can change direction better than you, or they can jump higher than you to head the ball. So, we've got to look at how each different sport works and try and learn from them where possible. And I actually think sometimes when you see strength coaches who have worked across some of those sports, it's fantastic because they'll bring bits from one to another. But a lot of people tend to stay focusing on the one sport, which isn't necessarily the best way to do it.
Well, this brings to mind actually a previous guest that I had. His name is Adam Story, and Adam was the strength conditioning coach for the Emirates, New Zealand Emirates World Cup team, that the sailing that won, sorry, America's Cup, not World Cup, but America's Cup team that won the America's Cup last. And he initially was with the All Blacks, or the New Zealand rugby team, and went from there over to train the America's Cup athletes. And he took many of the rugby players and put them on board the boat as grinders, the ones that are cranking and down in there. And he was doing testing on them, and the rugby players that he used to coach were inquisitive, just going, okay, well, how are these guys doing over there? And he said, you would not believe it. They will blow you away. Their VO2 max is so much greater than yours. Their power output it dwarfs anything that you're doing there. Just the specificity of training, taking just an amazing athlete and putting them into another environment, just fascinating when you see it. And of course, they go in and win America's Cup. But these rugby players who didn't know a darn thing about sailing were placed in this environment of conditioning, and they exceeded all expectations. So very fascinating. I can't believe we're coming up against the clock. We're about 45 minutes into it, and you've been very gracious and generous with your time. I can't thank you enough. Now, I do have a question in regards to the NSCA National Conference, which again will be July 12th to the 15th, where you'll be presenting Caesar's Palace in Las Vegas. Will you be, and as it's online as well as in person, will you be flying across the pond and being here in person?
Yep, I'll definitely be there in person. Because the one session I'm doing with Dr. John McMahon on the use of force plates is practical as well, we've got to be on site doing that. And we'll have a few other people helping us, no doubt, if there's a large number of delegates attending. And then I'll be presenting the Michael H. Stone Sports Science Lecture in person as well. So yeah, I'm really looking forward to getting out there and spending a bit of time in Caesar's Palace. I've been now to the NSCA conference. I think this will be my 4th time that it's been in Vegas and I've attended.
And so the real question is, what do you do in between lectures? And seeing that you're in Vegas, what is your go-to now that you're a seasoned veteran this will be your 4th time? Are you taking in shows? Do you have a certain do you like the roulette wheel, blackjack? Where do you go?
Well, I suppose during the day, it's normally just catching up with different people. So, I'll be out there a couple of days early to be able to sort of get a little bit of sun, have a few drinks, maybe have a bit of a flutter at the roulette wheel, and see if I can win a little bit of cash. But I probably won't. I don't normally. But yeah, during the conference itself, it's going to the presentations and catching up with people, and it's normally pretty hectic. But outside of that, in the evening, it depends what shows are on. I've never actually seen a show. This is my fourth time going to Vegas, and I've never seen a show because when I tend to get there in July, and it's always in July, the people that I want to see are on a break. They're not in residency there, so I'm going to have a look. In fact, my wife's coming with me, so she'll plan whatever we're doing. She'll plan everything out for the evenings and for the couple of days we're there beforehand. But yeah, it's just go around, have a look. The 3 or 4 years ago it must be 4 years ago was the last time we were there, and each time the bars, the restaurants within the casinos, they change. So you turn up a couple of years later, and there's somewhere else to go, and it's great. There's so much to do there. I certainly won't be going to any of the pool parties or anything like that. I'm far too old for that. Far too boring, and I'll have to get up and start early the next morning. So that's definitely not happening. But yeah, you might find me by the roulette wheel or at the bar having a few drinks.
Excellent. Well, tell your wife to look into a show called Absinthe, and just like the liqueur, I guess it kind of a raunchy Cirque du Soleil, but very entertaining nonetheless. We had a great time when we saw it, and I might just take it up again. But this has been great, Paul. For the listening audience that want to perhaps follow you on social media, understand a little bit more about your position at the university, how can they do that? Where should they go?
Social media, either Instagram or Twitter. It's at Paul Comfort 1975. Or otherwise, if they've got any specific questions, they can email me at p.comfort@salford.ac.uk.
Very good. Well, I'll make sure we put those in the description below the podcast. And well, I hope that we have a little bit of time, even just a few minutes in Vegas, where I can reach out, shake your hand, and we can chat. But I definitely will be in the audience for your presentations. I'm looking forward to it, and I can't thank you enough for being on. And I guess I'll just say I'll see you in July.
Fantastic. It's been a pleasure. Yeah, and I'll see you in July, and hopefully share a beverage or two.
And that's a wrap for this episode of the Zealous Podcast. And I just want to thank Paul for coming on. And also, if you're interested in either attending online or in person to the NSCA's National Conference this July, be sure to just check them out online where you can register, nsca.com. And we will see you next week.